Okay, so like I said before, this is going to be the method that I'm going to want you to use the most. So this is going to be a two-parter. I decided to do this problem, and then I'm going to end with the 3D problem for this. So, so really, you do the same thing. It's really just force times the distance to the line of action. But I want you to, but what you can do is you can actually break them up into components, and these components behave the same way as well, they produce the same moments in the end. So these components are going to have the same. Basically, we're still going to get m equals 4 Newton meters in the end. So yeah, so I'll just show you that. So if you break this up into components, you're going to have this is sine and then this is cosine. So as you can see, I did that right here. F sine, F cosine. So as you can see, if you're spinning around this point, the distance to this line of action for F cosine is 0, you know, because the line of action goes through the point that you're doing it from. So really this isn't going to give you any moment at all. So the distance is just 0, so you can ignore this force, or well, the component of this. So in the end, then you're going to have basically m then equals so you have your force, which is just F sine of theta, and then times by your distance, which is just r. So so, and like before, I'm going to draw a circle. So just to prove this a little bit more. So in the end, this is going to be your circle, and it's going to make it turn in this direction. Well, the F sine theta is going to turn in this direction. So, and that's going to be a positive moment. You know, it points outward when you curl your hand in this direction. So, so really, it's going to be a positive value. So your moment is then just going to equal 4 times by, well, yeah, I guess I have it right there. So it's just 4 for r times by F is 2, and then sine of 30 degrees again, and then we said it was positive in the end. So this is going to be a half, those cross out, and then you're just going to get 4 Newton meters again. So I prefer you to do it this way, just because it's just so much easier to break up things in components, and they have nice distances to the line of action, like very nice distances, you know. Just because you're in the Cartesian form already. So one thing before I end the video, I just want to point out is that in the end, last time we said this was D, but now for method 2.5, instead of saying that, we're saying this is just D, but now this is your force. So this was originally just your force, and this was both your distances, but now this is completely your force. So yeah.